Hi, this is my yet another OpenWRT board, and this thing is also MIPS based. I covered just yesterday a video about an x86 OpenWRT router. You can see here this thing is just a custom build. You can see here versus this thing is, it has a firmware and stuff like that. It was something I was working for some customer a while ago, and while doing some work it happened a situation that looks like the firmware build had some corruption in the file something, and it has bricked this device. Anyway, it has this serial interface. All I need to do is I just need to populate this to a serial port, and then once I get the access, I can go to the BIOS and I can just flash it once again with a working version. But it is something I have to do, and I thought it is interesting to discuss one more episode, because I was taking a couple of series on OpenWRT. You can see here a couple of days back I discussed about my other OpenWRT board, this thing. So this is quite different. This is this is that Dragino board. This is also MIPS based, and as well as this is MIPS based. So this has a processor which is the SoC, which is Ralink RT3050F. So this is that processor, the SoC, and this side you can see it has that memory. It is populated, and in the back side it has this flash. So that's the board. It is quite interesting, and it has this wireless radio capability. So you can see here it has this antenna, so you can configure OpenWRT to make it work as a wireless router and stuff. And besides, if you are even interested, you can add some functionality like some basic compression, encryption, and stuff like that. So since it is kind of generic, see, in this case they have populated these multiple Ethernet ports. Each of them, I suppose, is 100 Mbps NIC cards. And it has this inbuilt NIC card, and this thing is that the other port, they just color coded like a WAN port, but trust me, in the code, like I showed you yesterday, you can configure anything as anything. It will expose themselves as ETH 0, ETH 1, and stuff like that. So you can do it whichever way you want, but when they sell this as any commercial router or something, they can make this, they can populate this as internet or WAN port, and they can mention this as the LAN port and stuff. So that way, if you compare this thing or else that yesterday's x86 board, so what is the thing is, I can even show this picture. If I little scroll this side, you should be able to see the interfaces somewhere here. Yes, somewhere here you can see the interfaces. You can see there. I have put with a label printer as LAN and WAN. Right? There is nothing like LAN and WAN. You can make anything as LAN port and WAN port, or you can even make like a bridging interface, and you can make that entire thing to work as a Linux kernel bridging, like I showed you in the previous video. In case you haven't watched that video, I highly recommend you to watch the same, and even you can watch this Dragino board as well, because unfortunately this thing I can't boot and show any demo, but this is again MIPS based. I just opened these specs. You can see here this is Ralink, and you can see it's so and so, so and so, so and so. Somewhere they mentioned that it's a MIPS. You can see here it's a MIPS based board, and again it is not anything so much feature rich or something. So it is not anything like performance intensive and stuff. It's just a very basic platform for us to make any routing devices or anything like that. So of course this doesn't have any GPIO pins and all, versus this board has you can see here. Let me zoom a bit. You can see here, and let's get the focus. Yes, so you can see here it has these GPIO pins. Let me get a bit focus. Yes, so hope you can able to make out. Yeah, see, you can see here you have this GPIO pins, and in fact it has that driver support, everything for that, and it's just quite versatile board, and it has all this extensions, so you can put any hat which they sell, and you can make it as a LoRa stuff, and many things are possible. And this is the SoC. Okay, so this is what it is, and it's quite interesting. This board is quite versatile versus this thing is quite hardwired. Okay, so this thing is not possible because you don't have any such things, and in fact you can see here it has this wireless antenna which is also soldered and stuff like that. So like you can see there the processor and stuff. So this is what it is, and the backside is fairly simple. So this is what, so it's quite interesting boards like this, because what is the thing is let me get back the focus. I generally do manual focus in the camera, so I don't like any sort of breathing effect or something like that. That's what they call whenever you adjust or put the camera in auto mode. So I don't keep any auto settings in during the video capture, because this gives that precise control based on the lighting and based on the time I shoot these videos and stuff. So that's what, so I need to focus that lens each time whenever I do any changes. So you can see there, this is the board. So it's very, very interesting. This is almost like a complete finished product, and I have done quite extensive amount of work at some point of time. It was kind of interesting thing, because this is not like this. You can do many things with this type of a board, because it has more interfaces and stuff. So it's quite interesting in that aspect. So that's what it is. It kind of powers on since it has that firmware issue. It has that it kind of powers on, and after some time it gets it gets an issue because it has that firmware issue. The kernel is going to show the kernel panic, and kernel is going to have that kernel panic and stuff. I can't say the word show kernel panic because I need to populate this serial interface, and I need to debug, and before doing that I need to solder that headers and stuff, so that I can put that TTL serial stuff, and I can connect it to the minicom, and I can have a look exactly what is happening. So I need to do some work, and I believe it still has that U-boot or something like that. I need to still debug with respect to the same. So having said, some of the viewers have requested me to show a very quick demo of that Dragino board. I thought it is quite interesting to show in this episode, because anyway this is again MIPS based, and even this is MIPS based. This board is little bit bricked. What I can do is I can pick the other one which is kind of working, and then we can quickly hook to this system. So that's what I am going to attach, maybe these links. Before we do the same, I can show you a few interesting things. So you have this specs, and you have all the details about the processor and all that specs. Since I don't work in hardware level, I don't much bother about reading those aspects. Okay, other than that, I just need some basic specs and things like this. Because I do work on some amount of kernel optimization, and other than that I work mostly on network stack and things like that. So I don't much bother exactly what else it can do in terms of its hardware capabilities and stuff. And you have another page over here. You can see here RT3050, and again they mention it is so and so its specs and stuff like that, and it has so and so capabilities and things like that. Since it's a system on chip, of course it should have all this supporting features. It cannot be something like a desktop CPU where you put these things externally. You literally need to use that PCI lanes, and you need to put a NIC card controller, Ethernet controller. If it is a laptop, some wireless Ethernet adapter and stuff like that. Sometimes it may be PCI based, sometimes it is just soldered onto that laptop motherboard. Okay, so in this case, since it's a SoC, you have all the specs. And other than that, I was also got curious, and I'm checking in the OpenWRT what else you can find with respect to RT3050. Of course, it is quite old. That's why you get a lot of information. It's not anything, new board. It's almost a decade old. Okay, so that's what you can see. Various manufacturers are using this SoC. You have this Netgear, TP-Link. We can open some couple of them, and we can see that how their devices looks like. Okay, and you can see here even D-Link is there and stuff like that. So there are many brands using this platform. You can see there they have this type of a device. The end product, and yeah, you can see there they have put this picture, which is this which is why I'm saying it almost looks identical. You can see there, you have this internet and then LAN ports and then power, and similarly you can see here it has the same configuration, plus it has some extra things populated, and they have even put this USB socket and stuff like that. So that's all they provided, and some kind of a picture, I think serial port access, and yeah, that's all. So let us check this TP-Link stuff. You can see this is the TP-Link router. You can see once again some similar stuff. You can see the board looks completely different, which is not something like this, but since it is anyway the same processor, hopefully it is the same stuff should be there. So this is this MediaTek. I hope this is RT3050 inside. So I believe this is not the right one. I'm not sure. Blah blah blah. I don't think so. This is the same processor. Let's skip this. D-Link DWR512. Yeah, this has this RT 5350. Again, this is not the right match. I think it is just doing a rough guess when I searched. I think some are not the one which we are looking for. Let me check this Netgear. Is it the same one? MediaTek WAN hardware. I think again I picked a wrong one. I don't think so. Even this has that same processor. So we see which has that matching processor. So this is again Ralink, and I think it's not the one. Okay, so we just need to check carefully, and we will definitely find in OpenWRT. That's just not an issue. And sometimes you can even do some image search, and you can find tons of other boards which are using this same processor. So you can see here it is mentioned as RT3050F. Same thing even this board has, and this is in a different form factor and different configuration, hardware configuration, and things like that. You can find all these pictures, and also you can see that processors alone. Okay, so yeah, this is what it is. This thing is a router, Vive NG routers, something like that. This is in where is this link? This is going inside. We just to see where is this picture is inside. Okay, so this looks like quite an old stuff. So yeah, as you can see here, some other brand, okay, WR-150N or something using the same processor. Since it's it came in this high resolution. Yes, you can see there. Okay, it is using the same processor. In fact, this board looks almost identical, more or less to that. Of course, this doesn't have this pins and stuff like that over here. So I am trying to orient this towards that. So this is more like this versus that is more like that. Okay, anyway, hope you can get some picture. So RT3050F, and you have this memory over here versus here it is in some other direction and stuff. So same thing it is. So it's quite interesting. People who are very new to embedded development, one thing is either you work in platform level and you will work in porting, kernel porting, board bring up, and device drivers. And rather than device drivers, I should say that main platform level stuff you may be working on too. And guys like me, we work more on network stack and other networking capabilities and network performance and Okay, those kind of optimization. So it's kind of challenging to provide any decent performance on these type of boards if the kernel is not optimized, if the networking subsystem is not optimized. And even before I optimize the networking subsystem, the kernel folks, the platform guys does a lot of phenomenal work so that it is stable enough, and they are addressing all that issues and stuff. See, when they work on things like this, one of the main things they do, of course, is to strip down the kernel and stuff like that. And that is why we have this, entire ecosystem of OpenWRT and stuff. Because, this is not any, Ubuntu based laptop or something. You don't need any display drivers. You don't need any sound card and stuff. Okay, this is just a bare minimum board which has very limited functionality. This doesn't need the other extra drivers which you get typically with a full featured desktop with a full featured kernel. Sometimes there is an exception, although in the case of Raspberry Pi, they are providing a stripped down optimized kernel, but it is far more full featured than a board like this. Okay, so that's what. So this is many times faster when I compare to boards like this or this Dragino. Okay, so that's what I can do is I can just quickly fire up my Dragino, the working board, and what I can do is I can quickly show you that OpenWRT inside a Dragino, because earlier in the previous episode you have got a glimpse in x86. So this is the one. What I can do is I can connect to this LAN port, because this works again as a pre-configured router, and it is populating this and it is not populating this. Unlike x86, it is going to enable this WAN port as ETH1, but it is going to work and if you connect a cable or something, it is going to come up, unlike that x86 stuff, because x86 is a generic OpenWRT versus this is a ported, and some amount it has been pre-configured. Okay, so that's what. So let me connect this cable to this WAN port, and let me connect also this stuff. Okay, power button. So it is booting up. Hope you can see here. Okay, so yeah, you can see here. The other board, which is dead, it's not going to show any status LED because its kernel is screwed up, and it is showing some kernel panic. Okay. So the other day, one of my student came and we are debugging that, and he got that serial connector. So we found that it is showing that kernel panic, and I thought let me take some time and think about what I can do with that. So let me go to this network connections over here, and I can add one duplicate IP over here. Let me see if that hack works. Okay, 168.1.2. I don't need to configure any router. Okay, so let me save the same, and I can disconnect. I can connect back. Yes. So the 0 subnet, if config 192.168 0 subnet is that home Xiaomi Wi-Fi router, and the other one is going to be this. So sometimes you can enable anyway multiple IPv4 addresses to the same port. Okay, so this is quite common in V6, but V4 it is not that common. Okay, so it is anyway. Ping 192.168.1.1. Yeah, you can see here I can able to ping this Dragino, as well I can able to ping as usual to my Wi-Fi router. So it's kind of you can imagine like multi-home, something like that. So I'm not sure about the term, but anyway, so you got the picture. So I can do SSH root at 192.168.1.1, and it is going to accept. Yeah. So the default password is Dragino, and we can go inside, and I can do this cat proc CPU info, and you can see here it shows this Athros, and it is AR9330 versus this one is this RT3050F. Okay, so this is a different processor versus that's a different processor. I'm not sure which is faster and which exactly came first. Okay, I'm not sure about it. I still believe this this one is quite recent. I'm not sure, it's just a gut feeling, because this is quite recent to turn out versus that one is really old architecture. Okay, but having said, it is still being used. It's an industry tested architecture and SoC, so it is going to lay around for some more time for small applications. Okay, yeah, you can see there the CPU model is MIPS, and it has no more cores other than just one core, so it is just one instance, CPU instance, and few more capabilities and stuff like that. So since it is MIPS uname -R, it is running this old 3.10 kernel. It is not a 4.x kernel, which you see in in the yesterday's video in that x86 based OpenWRT, because I pulled the most recent OpenWRT and it happened to be having some 4.x kernel, I suppose. Okay, versus this is quite old build. This is around 2016, 15, 17 time. Okay, so this is quite old. Other than that, you can't run a few commands like lscpu and stuff, because it is a very fairly simple embedded Linux. Okay, so it's just very fairly simple stuff. They can't put any full featured, like I said in the yesterday's video, you can't put man pages and stuff for something like this. Okay, so it's going to be fairly limited. So you can see there the status LEDs and stuff. Okay, hope the camera is able to focus. Yes, so that's what. And if I ping anything, it is going to show the status or activity 192.168 1.2 something, and you can see there it is blinking, and they have marked it as wireless wired Ethernet for these corresponding LEDs. So this is one and this is other one, and this is the wireless radio. Okay, so this thing, I don't think so it has inbuilt radio. This doesn't have that. So having said, what is the thing is, this has this weird provision. Okay, so let me get this focus out. Yes, it has this weird provision. Okay, here you can see there's a small notch or some kind of a cutout. You can cut this plastic, and there are some variants with that wireless functionality. If you go to this Dragino website, you can able to find out. So yeah, that's about it, and it's a very small embedded Linux. So again, unlike x86, if I do free command here, you can see it has around 61 or 62 MB of RAM, and that's all. Okay, so it has only that much of RAM, and it's fairly small. Okay, when you compare to my system, you can see there open tab default free, it has this 16 GB RAM, and free I can even type -h option. It shows in human readable form, which is 15 GB around, whatever it is, and which is nothing but 16 GB DDR4. So that's what it shows like this, and you can see even it is using the swap space and stuff, versus in this case I think they have disabled the swap memory. Of course you can't use for something like this, and you can't do anything like free -h and stuff. Okay, it doesn't work, and moreover, like I mentioned yesterday, man free, nothing it works, because it's a very stripped down Linux distro. Having said, it is again interesting if you do ifconfig. You can see here it has this BR LAN and a similar configuration, but unlike the yesterday's x86, this thing at least it is showing up. Okay, so and if I do something like brctl show, it shows that the bridge association with that LAN port. Okay, the main thing is, like I mentioned in the yesterday's video, in this type of hardware, there are many LAN ports, but all of them are configured to the same bridging interface. So naturally, this is like a software switch. So they are giving us free switch with 4 ports. Okay, so that's what you are getting, an entire cheap bundle when you buy this type of wireless routers. Okay, so you get this multiple LAN ports. All of them are configured like a software switch. So this is what essentially you get, versus if you buy a real switch, the switching happens in the firmware, versus in this case the switching happens in this Linux kernel. Okay, so that's what so this Dragino board, since it has just 2 ports, one have to go for WAN port and one have to go for LAN port, so they have just associated just one port to this BR-LAN. Okay, but again, having said, we can again do this BR-CTL add if you can add this BR-LAN and you can add this ETH1. It should work fine. Okay, BR show, and you can see you can change it, and now there is no WAN port. The entire this thing is going to work as a network switch. Okay, so network switch or bridge, whatever. So it is going to work as a layer 2 device. The moment you do this, it's going to work as a layer 2 device, no more as a router. Okay, although the kernel has this setting enabled. Okay, proxys net IPv4 IP_forward. You can see there they have enabled the same, but although it is enabled, it is not going to work as a router the moment you set something like that. Okay, so it's quite interesting. Again, I'm not that expert in terms of CD/etc. I'm not sure what could be its config. So we go to the config folder and cat network. You can see that this has more configuration which is set, unlike the yesterday's x86. So here, if you want that to be permanent, you can comment these lines. Okay, so you can comment these lines, and you can configure the other interface also as a member of that bridging interface. So all those things are possible. So that's what. Same way, in the yesterday's x86, if I want the WAN to be enabled, the other port to be enabled as a WAN port, I have to add these 3 lines in that x86 device. So this is what it's kind of simple, but it is nowhere like what you do things in Ubuntu or something. You go here, you set there, you do something in this GUI, and sometimes you do some goof up, it will work, it doesn't work in the stuff, and moreover you have this thing called network manager in this Linux desktop distributions. Okay, there is something called as Linux network manager. You can try that sudo dpkg --list and grep as network manager. So you can able to see somewhere it is going to show this network manager. Okay, yes, so you can see here this network manager stuff. So you have that network manager thing. Okay, so this is what it is. You can see there, and they have this module name as called as libnum and stuff. So this is what it controls, that networking stuff in this these kind of desktop systems. This network manager itself came around quite recently, around 10 years ago or something. Before that there was something else, and you need to use that etc config files and stuff. Okay, so this is quite recent, and after this came, it's more easy to set any networking configuration settings in a desktop Linux desktop systems than what it existed in the past. Okay, even being an expert in networking, even I used to struggle configuring those etc scripts and stuff. This is quite simple, but if you have something like Ubuntu server or something, still you need to configure the network interfaces through etc settings, or you can use some CLI tool and stuff. Okay, so coming back, you can see it has this stuff. It has some more presets and stuff, which is tells the story that this is full fledged hardware to do something, rather than like yesterday's that x86, where I just grabbed that OpenWRT. I just put on that x86 routing hardware, and still it has to be configured and to make it work and stuff. Versus here, it's a pre-built embedded board, so they know it is going to have this 2 ports only. Okay, so there is no question of adding extra additional ports. Having said, sometimes you can extend by putting this this let me just grab this. Yeah, I have done that in the past. Sometimes you can do some hack of adding something like this and add an extra Ethernet port. I'm not sure, it may work also in this case. Okay, so let me just plug this adapter to this stuff. I never done this, or I must have done, I forgotten. So let me just plug the same. So you can see here it is plugged. Let's not bother about whether a cable is connected or not. Okay, we can just do an if config and let's see if kernel detects and it shows up. So it is not showing up. We can do sometimes if config -a if it is disabled or something like that. Okay, yeah, it is not showing up, and I'm not sure how come this WLAN 0 is appearing. I am really not sure whether it has a inbuilt radio or not. It has some antenna provision, but I never checked it. Okay, so this is the first time I'm also seeing. I am kind of excited that it has some, you know, wireless radio or stuff. I need to poke and experiment. Maybe I can get this antenna and then plug over there and see that if it really comes up once I do the settings in that etc config file. Okay, network config file. So before I go, I just suddenly remembered I got a query. Someone asked me, since we are not shutting down and we are just powering off this Wi-Fi routers or whatever, these type of devices, what will happen to its configuration? Again, I want to say that it's just a stripped down version of Linux. It is not something like a desktop where it is going to access thousands of files with a lot of daemons running and stuff. This is quite, simple. You can see here PS, if I type it as, few, this thing running in the background. So it is not anything like a huge desktop system. Nothing is going to happen. And still, if you care about and something like this, if you are connected or something, maybe you can do some graceful, power off or halt or something like that. Okay. See, the moment I did, I lost the connectivity. I'm unable to ping that, reach that device. So it is going to do that shutdown sequence. So it's interesting. Okay, so it's interesting. If you are new to this ecosystem, you can go through that OpenWRT documents, and if you have anything to discuss, be in touch via mail. And generally feel free to post your queries in YouTube comments, and if it is happened to be quite lengthy discussion or something, then you can send a private email. And also, in case if you want to discuss something in private, you can be in touch via mail. So in case if you love videos like this, support the Linux channel, and also please hit the like button and do subscribe to Linux channel if you haven't done. So thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.